there are two factors can influence the bus stop capacity. The first is the loading area provided, the number of loading area provided, and the second is the loading area design. The bus stop sign and also the number of loading area in the bus stop is constrained by three factors. The first factor is depends on the block length, so the size of the bus stop. The second is the location of the bus stop along the busy road and less busy roads. And the third factor is whether there is an on-street parking before and after the bus stop. It will affect the capacity of the bus stop. As we know, when we increase the number of loading area per bus stop, it will help to increase or improve the capacity. But our advice is, if more than 3 loading area at the bus stop, then the passengers may confuse because they will take time to find the bus, the right bus to ride. So lead to longer due time. We can see two pictures. One is the online bus stop. Online bus stop means that when the bus stop in front of a bus stop, it will occupy one lane of the traffic, so it will affect the traffic flow. On the right offline, so means that when the bus stop in front of the bus stop, there's a bay for the bus to go into the bus stop, and it won't block the traffic of along the routes. Refer to the first bullet point. It says that offline bus stop will have higher capacity than online when 4 or more than 4 loading areas are provided. But if you only have 1 or 2 loading areas, seems that online bus stop provide higher capacity than offline. How about 3? When we have 3, there is no difference between in terms of capacity between offline and online. So perhaps we will think that if we go for offline, we can have more loading area, then it will give us the higher capacity. But don't forget, when a bus leaving the offline bus stop, it will take longer time. It will delay because of the traffic. It will take longer time to join the traffic, except the speed limit on the street is high. For the bus to find the gap to join the traffic. Again, you have seen this figure before. So we have near side, we have mid block, and we have the far side. Advantages for far side bus stop, there are 4. The first is minimize the conflicts between right turning vehicle and buses. Second, it may encourage the pedestrian to cross behind the bus, but of course it depends on the distance from the intersection and the bus stop. And the third point is create the shorter deceleration distance for buses. Because before the bus reach the bus stop, you have to pass the traffic light junction. Either it stop at the junctions or at least it slow down. Then this will help the bus to slow down and to reach the bus stop. And the fourth point is buses can take advantage of gaps in traffic flow created at the signalized intersections. So these are the 4 advantages for far side. There are 4 disadvantages for far side bus stop. The first one, it could result in traffic queue into intersection when bus stop in the travel lane. So means that the bus will occupy one lane and always will refer to the online bus stop. The second, it may block the sight distance for the crossing vehicles. And the third, it may also increase the sight distance problem for the crossing pedestrian. It will block the sight, the view of the vehicle crossings, and also for the pedestrians. And the last one, it may increase the number of rear end crashes. So some vehicles don't expect the bus after it passes the traffic light junction, it have to stop again. So that's why it will increase the likelihood of the rear end crashes. That means that the vehicle crash the back of the buses. There are 3 advantages for near side bus stop. It will minimize the interference when traffic is heavy on the far side of the intersections. That's one. Second is it will eliminate the potential for double stopping for bus. So especially during the peak hour, when there are many buses want to stop at the bus stop, then it will block the traffic flow. And the third point is to allow passengers to board or alight while bus stop for red light. So means that when the bus leaving the bus stop, it has to stop because of the traffic light, and some passengers still have the chance either to go into the bus or leaving the bus. There are 4 disadvantages for near side bus stop. First, it increases the conflict with the right turns mean vehicles. So we refer to the driving at the right hand sides. The second point is may result in stop buses, obstructs curbside traffic control devices, and crossing pedestrians. So because of the bus size is large, it may block the view of we can't see the, like for example, the road signages, stop signs, and others important signages. And also we cannot see if any pedestrian cross in front of the bus. So the third point is may cause sight distance to be obscured for side street vehicles stop to the right of the bus. If we allow the on-street parking, so this will also give some problem to the vehicle parked at the roadside. And the last point is increases the sight distance problem for the crossing pedestrian. This is what we also mentioned in the second point. The mid-block bus stop advantages. First, it will minimize sight distance problem, like what we can see in far side and near side bus stop. And the second point is if the number of passengers is large, so mid-block bus stop has bigger area to handle them. And for mid-block bus stop disadvantages, first, it required additional distance for no parking restrictions. So we don't allow parking on street parking before and after the bus stop. So therefore, if we have mid-block bus stops, it will reduce the number of on-street parkings. And second, it will encourage passengers to cross street at the mid-block illegally. And the third point is increase the walking distance. So because of the location of the mid-block is in the middle of the street, that's why the passenger have to walk for a longer distance to the bus stops. This slide shows the design of the bus stop. Top we have two, refer linear and saw-through, refer to online bus stop. Linear bus stop is commonly seen in the urban area. Saw-through is not recommended because of it restricts the movement of the bus. And the bottom two we have drive-through and angles, and these two refer to offline bus stop. The main difference between drive-through and angle is for drive-through there is the platform between bus, and the purpose of this platform is for the passengers to stand safely when they are about to board or alighting from the bus. And for the bottom two, it will double the stop total bus capacity. As I say, offline always better than online in terms of capacity. And move independently. It won't block among each other, unlike linear and saw-through. And buses are typically assigned to a particular loading areas. So means that it will label bus going to the destination A, B, C will occupy a specific loading areas, so people can find their bus easier. And of course, these two bus stop, drive-through and angle, is not commonly seen in most of the urban areas, but sometimes they are quite useful because of they will increase the capacity of the bus. Linear bus stop is the most common online bus stop. Usually it only have 1 or 2 loading areas. When we have too many loading areas for linear bus stop, it will become less effective for 3 reasons. First is real loading area will be used less often. Second is passengers will get confused, and this will increase the dwell time. And the third one is if the distance between the bus is too short, then it will restrict the movement of the bus, and this also will increase the dwell time. Linear bus stop become more efficient when bus move in platoons. This can be done by having special design bus timetables. The tables show the bus. There are 3 scenarios. One is random arrivals, second is platoon arrivals, and these two are referred to online bus stop, and the last one is for online bus stop. So we have now different number of loading areas. For random arrivals, the efficiency start with 100%, But when we have more, like for example, when one loading area move to 2 loading areas, the efficiency becomes 75. Okay, for platoon arrivals, okay, when we have 2 loading areas, the percentage is still higher than random arrivals, 85 for platoon, 75 for random arrivals. But for offline, we can see that it will have the first is 100%, second loading area 85%, third is 80, is still the same compared to platoons. And but when we move to number 4 loading area or 5 loading areas, you still can maintain 65 and 50, but for platoons it already dropped to 25 and 10. So this also can indicate how the offline bus stop can increase the capacity of the bus stops. And this table show, okay, the capacity of a bus stop with different value of due time, number of loading area, and GC values. So we can see that, okay, when the due time increase, the capacity drop, okay, from 48 to 15. When we compare GC 0.5 and 1, GC1, okay, the capacity is higher than GC 0.5, 69 is higher than 48. Okay, when we compare 5 with 1 loading areas, 5 loading area we have 133 capacity, but for 1 loading area we only have 48. Okay, this slide explains the factors affect the bus loading capacity, bus stop capacity, and also the bus lane capacity. For bus loading area capacity, in general there are 4 factors: due time, clearance time, operating margin, and the traffic signals. So you can see for due time, okay, there are 3 factors, sub-factors. It depends on the passenger volume, the fare payment method, and also the vehicle design. And for the clearance time, case depends whether it's online or offline bus stop. Of course, offline will take longer time. And also the curb lane traffic volume depends on the traffic flow along the routes in front of the bus stop, and also whether there is a yield to bus law or not. Okay, operating margin depends on the passenger demand volume and also the design failure rate. And the last one, the traffic signal, depends on the green time ratio and also the bus signal priorities. And this we will look at this in more detail in the next chapters about the bus signal priorities. Collectively, all these factors affects or determine the loading area capacity. So, and for bus stop capacity it depends on the number of loading area and also the design of the loading area. And the bus lane vehicle capacity, it depends on the bus lane type, bus operations, and critical stop conflicting volume. So these 3 factors will be seen in chapter 2 and chapter 3. So this slide explains generally, okay, how are we going to change the factors levels in order for us to maximize the capacity for the bus lanes. And this slide explains the factor influence the person capacity. So there are 3: agency policy, passengers demand characteristic, and also the vehicle capacity. So the first factor, agency policy, it depends on the policy. It's not only the policy set by the government, also the policy set by the bus operators, the passenger loading standard, and also the bus frequencies. Okay, the second one is passenger demand characteristic, the peak hour factors, passenger trip length, and the boarding volume at the critical stops. And the last one, okay, is what we explained in the last slide. It depends on the loading area, bus stop, and the bus lane capacity. So these altogether, these 3 factors will affect or influence the person capacity.